Hi, I'm Nathan Shively-Sanders, and let's talk about parsing in Typescript. So before I start, you really do need some background to watch this. I'd recommend Orta's How the Compiler Compiles, right here, because I'm going to talk about how parsing works, but I really want to get across the idea of how it works. I'm going to assume that you know what parsing is and why you would want to use it in a compiler. So you could also probably use a compiler textbook as well. But Orta's video is really good, so I'd recommend that. So before we start, a little bit of background about me. I've been parsing for a really long time. All the way back in college, I applied compiler parsing algorithms, the ones used for computer language, to natural language. And this was the era of Python and CGI bin, so I had a web page that tossed it at a Python script, which was fun. And because it was Lord of the Rings mania, I reused exactly the same parser and made a highly impressive Quenya parser by taking a tiny Elvish grammar and turning it into a 4-different class. So that was fun. I continued parsing throughout my career all the way up to when I joined the Typescript team, and about a year after that, I heard Ryan at his computer muttering at trying to parse some JS doc, and I walked over and said, "Can I help?" And I've been parsing in Typescript ever since. So this is sort of the standard what is a compiler slide. Once again, Orta's video is a good place to understand this stuff. One note, I have Lexer here. I kind of switch back and forth between Lexer and Scanner and use them interchangeably. So a scanner is a process that takes a string, that's your source file, and returns a list of tokens. And a token is an enum that chunks up the source file in some way. So some example tokens, like you have semicolon and white space, that's punctuation. Typescript often calls this trivia, and that kind of structures your source file, but it's sort of optional stuff. Then you have const and function keywords, and those strongly structure your source file. But they don't have like specific meaning for your program necessarily. The content tokens do. That's things like identifier and literal. And interestingly, the scanner and parser don't actually care about the content of identifier and literal. They're concerned with structure, but they do save the content because the binder and checker, for example, need to know the difference between const x and const y. Another interesting point is that scanning is actually an iterative process. Although you could create a list of tokens, it doesn't. And parsing actually is iterative as well. It's a left to right process that scans along a string. Well, not a string. It scans along a list of tokens and produces partial trees until at the end you have a complete tree. But it never actually looks at the entire token stream. What it's going to look at is a single token, the next one in the iterator, and based on where it is and what it's looking for, it will decide what to do. So it's making decisions based on its current context, which is really only one token ideally. So making decisions based on what just happened and what you're expecting to happen, and a tiny bit of context should sound awfully familiar if you're familiar with like the way current AI systems are working. And the natural language processing in our brains probably happens somewhat like this too. So it's a common architecture. And that's really the idea I'm trying to get across in this particular video, is that we're not looking at the entire thing. We're progressing left to right along this stream, building up partial information as we go, based solely on local expectations. So let's look at an example. When you first start parsing, you're looking for a source file. And a source file has statements. So in a recursive descent parser, like Typescript, you're going to call a function called parseStatement. Other systems might have like a rule file that has a statement rule that tells you what to look for. In TypeScript's case, you're going to say parseStatements, and then a statement can start with any number of keywords like const, let, function. So basically what you're going to do is when you're parsing a statement is look at the next token and say, is it a const? Ah, I'm parsing a variable declaration. Is it a function? Ah, I'm parsing a function. Is it let? Oh, I'm parsing a variable declaration. And so on. And then you'll call the appropriate function. And so you just call recursive functions all the way down. But at each step, you're really only looking at one token here. So once we're in parse statement, parse variable declaration, the first thing that's going to do is move the scanner over by one. So it's going to bump the pointer, and it will start looking for the fields that it needs to fill out. So a variable declaration has a name, a type, and an initializer. Now type and initializer are optional, and we can talk about that in a second. But the first thing it's looking for is a name. So what it's going to do is call parsed entity name or parse name or something like that. And in JavaScript, names can start with one of three tokens. You either have an identifier, which is like the normal case, obviously, but then you have square brackets and curly braces if you have destructuring. So if this was like destructuring a tuple with square bracket x comma y, then the token you would see here would be a square bracket. And then you would know, I need to parse a destructuring. But in this case, we just have the simple case identifier. So we construct a identifier and return that to variable declaration, and we'll bump the pointer. And then variable declaration will say, okay, I parsed a name. Now I need to find out, am I looking at a type? And conveniently, types always start with colon. So you can look at the next token. Is it a colon? Yes, it is. Yes, we have a type. Now, if you didn't have colon number, you'd be looking at equals. And in that case, the variable declaration check could say, is my next token colon? No. Okay. Is my next token equals? Yes. All right. I have an initializer. And of course, if you have nothing of those and you just have const x semicolon, then variable declaration would say, well, I've checked for the two things that I'm looking for. They're not there. I'm done. And then something else will parse the semicolon. Up here in statements, probably. Okay, so let's go back to types. So once you've seen the colon, you're inside of you can call parse type, and parse type will also look for pretty much the same characters actually start types as start identifiers. You've got identifier. Names and types start with more or less the same tokens. Identifier, square bracket, curly brace. I think types can start with some more things like angle brackets, but in this case, we once again have just a single identifier, the simple case. So we can return immediately and after constructing our identifier. One thing to point out that computer languages have unambiguous things to check usually. So at each point, we can check to find out if we have a type by looking for colon. And if we do, we have a type, otherwise we definitely don't have a type. Natural languages are not structured this nicely, but computer languages are usually structured so that the left-hand side of any particular thing you're going to start parsing, say statements, have unambiguous keywords or syntax in that location. And that makes them much easier to parse than natural languages. And usually it's unambiguous. You can always just know, hey, I'm looking for this exactly the one thing, and if I have it, I know what I'm parsing. All right, and that's it for this video. The next one we'll actually look at some code in mini Typescript.